Welcome to this lecture on aggregation. Often you will see that objects are made up of other objects. So there are relationships between objects. Has a is the relationship that we are going to discuss in this particular presentation. It represents a form of composition. It forms critical building blocks of many applications. At the end of this video, you should be able to understand how aggregation represents composition, identify the role of aggregation in real world, use of that in applications, and describe aggregation difference between composition. Let's start with has a relationship. Aggregation represents composition, which means whole part relationship. An object can be a whole object made up of parts of objects. Object A belongs to object B, or object A is part of object B. In both cases, we say object B has object A. Object A is often called as constituted object, a part, a constituent, or a member object. On the other hand, the object B is called as the composite type because it has other objects. UML, or Unified Modeling Language, allows us to pictorially represent these relationships. Here is an example of how a composite and constituent are related with each other. Observe the filled diamond on one side of the relationship. So that's where we say a composite has constituents. So you shouldn't put the diamond in the other side. You also will see multiplicity indicating how many objects are part of how many composites. Some examples. Now, aggregation combines simple objects into more complex ones. You will see them in many data structures such as tagged unions, linked lists, binary trees. A car, for example, has steering, engine, seat. So we can represent the same thing in this fashion. We can say a car has one engine and car has one steering. If you look at the engine's perspective, one engine can be part of 0 or 1 car. So I can take an engine out of the car and keep it aside, so it's not part of any car. But if it is part of, it will be always part of one car. And the same thing goes with steering as well. Here is another example. A university has department. A department belongs to university. Now this is a composition relationship. A composition also says that if a university is shut down, the department is also gone. Now some of the points to note here. When the owning object is destroyed, so are the contained objects. For example, if the university closes, the department will no longer exist. A constituent can be part of only one composite. So a department can be part of only one university. An engine can be part of only one car. A steering can be part of only one car. If you think of a laptop and a processor can be part of only one laptop. Now this is a very strong relationship, which is what is called as composition. On the other hand, aggregation is a variant of composition. It is a form of composition where composites does not imply the ownership on the constituent. So that means there is an object A that has another object, but it doesn't have ownership. Destroying object A not necessarily means object B is also destroyed. Now, UML representation of aggregation is very similar to that of composition, except that the diamond is not filled. The rest of them remains the same thing. In this scenario, we are talking about a department has professor. Now, one department may have 0 or more professors. 0 or 1 professor may work with 0 or more departments. Now, constituent continues to exist even after a composite is destroyed, which means if department is closed, then if the university closes, the department will no longer exist. However, professors in those departments will continue to exist. They may even go and work somewhere else. A constituent can be part of more than one composite also, which means a professor, for example, may work in more than one department. There is no tight association between them. So some of the key points that we discussed in this video are: aggregation represents Hazer relationships, and it is a form of composition. Aggregation forms building blocks of data structures like tagged unions, linked list, binary trees, and so on. Composite does not have ownership on its constituent in case of aggregation. A constituent can be part of multiple composites and can exist in even if there is no composite.